So I know I teased you a bit in the last video where we set up the Pixie booting server using Alpine Linux. I promised that we would come back to the Proxmox VDI Thin Client and boot that using Alpine Linux. So today I've delivered. Here it is, up and running. Alpine Linux running the Proxmox VDI Client, network booted from the server we set up in the last episode. So today we're going to walk through how we configured Alpine Linux to launch the VDI client, and how we export that configuration as an APK overlay so our Netboot system we set up in the last episode can netboot this overlay and configure this for us. Of course, there's endless possibilities with netbooting in Alpine Linux, and I'm just scratching the surface here of what's possible. If you have anything else you want to try netbooting, let me know down in the comments. I'd love to hear about it. I do promise I'll get back to the Raspberry Pi, but today, x86. So let's get started on this adventure. So quick interjection here from future Applard while I edited this video. This video is part of a series, so if you haven't watched the previous episodes, you're probably going to need some of that information going forward. So if you need help setting up Spice on the Proxmox side to allow Remote Viewer to work, go down to the description. There's a link to a previous video at a specific timestamp where I talk about that. We need to create a new virtual machine, and we're just going to use this to set up what our thin client's going to be. So we're going to use it to generate that APK overlay file. And so we're going to launch the Alpine Extended ISO, and we're not even going to give it a disk. No disk. And dual core. RAM is a little bit important here. Give it at least as much RAM as your thin client's going to have, because it's going to download a lot of stuff into RAM temporarily. So 2 gigs should be fine. Networking, go. So we came up on our Alpine virtual machine with no hard drive, and we're basically going to configure this system exactly how we want it to be the thin client. And we're going to use this as our image. So we're going to log in as root again, and we're going to run setup Alpine. We're going to give it some different answers this time. So first it asks for a keyboard layout, which is US and US. Now it asks for a host name. I'm just going to call it thin client. And available interfaces, ETH0. So we want to initialize ETH0 for Ethernet. And we want to use DHCP. And DHCP is pretty much your only option if you're netbooting, because you could potentially use this image on hundreds of clients at once. So we got an IP address, it's .9.31. So next up we have to set a root password. We can choose whatever we want. Okay, which time zone are you in? No proxy URL. So here a mirror of 1 is the default. We're going to choose 1. So that's dlcdn.alpinelinux.org. Which SSH server? We're going to pick none. We don't want anyone logging in by SSH to our beautiful thin client. No disk available. Try CD-ROM? Yes. Now it says, which disk would you like to use? The 0.7 gig drive is actually our boot image, and we're going to say no. We're not going to install it. And where would you like to store configs? And again, we're going to say none. Where do we want the APK cache to be? And we're going to say none. There we go. Done installing. So now we are going to install Nano. So we have a text editor. So APK add Nano. Let's see what it set up for our repositories. Okay, so there's two repositories that are enabled here, the CD-ROM and main. So we need to comment out main and uncomment community. So we want dlcdn.alpinelinux.org, main, and community. So we're going to save that. That's Etsy APK repositories. Okay, so since we want to run a graphical system, they have a script for us that does that. It's called setup xorg base. Setup xorg base. That should install a bunch of stuff. And we're happy. Now we're going to install the rest of the packages we need. So we need Openbox, Xterm, Terminus font, Fontnodo, Python 3, Python 3 pip, so py3-pip, PySide2, which is the Python Qt library, py3, PySide2, Vert Viewer, which includes the Remote Viewer package, and Git. We could potentially put our VDI client as the root user. It wouldn't be super insecure because this system doesn't really have any storage. There's really nothing they could do. But we're going to create an unprivileged user anyway. We're going to name it VDI. Now we're going to give them permission to the input and video devices so they can start an X server. And just for fun, we're going to edit the message of the day. So we got this long, beautiful thing here. And we're going to replace some of this with a fun text of our own. So if someone sees this, they should probably reboot the system. So it'll re-download everything from Pixie. So now we're going to log in as the VDI user and configure the client. So we use exit to log out. And we log in as VDI. And it warns us we should not see this message. So now we're going to install our pip dependencies for Python. So pip3 install Proxmoxer, which is the Proxmox API client, and pi simple GUI. Spelled it wrong. There we go. And notice it installed version 0.30, and we actually want 0.35. So it thinks that it can't install 0.35 because there's no wheel for PySide 2. But we already installed PySide 2 through APK, so we're going to force it. So we're going to force it to be 0.35.0 and say no dependencies. There we go. So now we're going to clone Josh Patton's PVE VDI client, the same one we used in the last video. Of course, if you want to set up an appliance for Firefox or for Remina or something like that, you're welcome to do so. This tutorial should be pretty close for you, but we're going to set up the VDI client that I've used in previous episodes. So we cloned that. Now we're going to make it executable. Plus X, home, PVE, VDI client, VDI client.py. Now we're going to create a directory for the configuration file, which is make dir-p home/.config/VDI client. And we're going to create the configuration file. There we go. So if you go to the GitHub for PVE VDI client, there's an example configuration file that has a lot of information that's useful. I'm going to set some basic stuff up. If you'd like to customize this, of course you can. So the general section is the look and feel. So you can name it whatever you want. Name it after yourself, name it after your company, whatever you want to do. And again, the theme, there's a lot of flexibility in the theme. I like dark amber. So we're going to use dark amber today. You can pick whatever theme you want. And icons and logos. If you would like to use a custom icon or a custom logo, now would be the time to get it. So you should probably download it over HTTP using like wget and put it in the user VDI's home directory. And then put the absolute path to the icon and the logo here. So I'm going to use the one that came with the VDI client. So home, VDI, PVE, VDI client, which is where we cloned the Git repository. You can, of course, put your own icons here if you want. Next up is authentication. So if you're using Proxmox local authentication, the realm will be PVE. So auth backend, PVE. If your Proxmox server is using something like Active Directory or LDAP, you would put that here instead. And you would probably know what the value should be. Next is if you're using TOTP authentication or one-time passwords. In my case, I'm not, so I'm going to put false. And last option is if you should verify the TLS certificate. If you're using self-signed certificates, you have to set this to false. Next up, we have our hosts, which is our Proxmox servers. And you can, of course, put all your servers here. So the DNS name or the IP address equals the port, which should be generally 8006. If your system is such that you can't resolve Proxmox's name via DNS, Proxmox is going to return its own DNS name in the Spice config file it returns. There's a way to rewrite those using the VDI client with some additional information in this INI file. And if your network doesn't have a DNS server that can resolve Proxmox's DNS name, then go read that config file and add that additional information down here. I don't have that problem, so I'm going to save. So now in theory, we could launch the VDI client and be ready to run. But the X server is not ready to run, so we need to do that first. So first we're going to set so that when the user logs in and their profile is executed, it immediately starts the X server. So echo exec start X. That's going into the file home/.profile. This is similar to like a bash RC, but Alpine Linux doesn't actually use bash, they use ash, so .profile is the file we need. Start X. And then when X starts, it needs to know that it needs to launch Openbox. So it needs to exec Openbox, and that goes into the file home/.xinit rc. And finally, we need an Openbox config. So we're going to copy the default. So /etc/xdg/openbox into home/.config. Now they have an auto start file that starts up some basic stuff, and we're going to get rid of that and write our own. So remove .config, openbox, auto start, and create one. So this file gets called when Openbox starts, and we're going to create what's called a run loop. So if the VDI client quits for any reason, it gets called again. So while true, do home/PVE VDI Client /VDI Client. Hi. Done. Save. So at this point, if we were to log out and log back in, it should start X. But we're going to start X right now just to make sure it works. And there's the VDI client, and we can't quit it. But what we can do is right-click here, and you'll notice there's a bunch of programs here, and none of these are installed. So if we click on them, we just get an error. But one of them is installed, and that's Xterm. So now we're going to kill all X in it. Takes us back to our user. Now we're going to log out and log back in. And when we log in, we should end up going straight into the VDI client. So exit logs us out. We're at the login screen. We log in, and boom, there we are. So if we do the Xterm trick again, and if you're trying to debug, by the way, you can launch things from the Xterm if you can't get it to work right, if you want to see the error messages in the VDI client. Now would be the time to debug this before we go further and netboot everything. So now, when we kill all X in it, we end up getting logged back out. So now that we've confirmed that the VDI client is working when the VDI user logs in, now we need to take this system and make it a template. So we're going to log in as root again to do that. So the final configuration step we have here is we want the system to log in as VDI automatically. So we're going to edit the init tab to do that. Nano etc init tab. So we have a bunch of gettys, and we would like to, instead of calling tty1 with sbin getty, we're going to call tty1 respawn bin login -f, which means force, or the user's already been authenticated in VDI. So when it spawns tty1, it's going to call login VDI instead of getty. And then we commented out tty1 for getty. We're going to save that. So now if we were to reboot the system, well, we would lose everything because the system has no persistent state. But if we were to install the system and reboot it, it would log in as VDI. If we logged out of VDI, it would log us back in as VDI. And if we were to somehow exit the X server, it would log out and log back in again. So there's basically very few ways the user can mess this up. So one more thing we're going to do is we're going to delete the ash history. It's similar to the bash history. And it's just a general thing we should get rid of because we're going to package the system up. So you can see here, if we look at the user VDI's home directory, there's a file called ash history. And that's all the commands we just typed. So we're going to get rid of that. It's gone. Basically what's going to happen now is we're going to generate what's called an APK Overlay file. And this file contains the contents of etc, which are the configuration files for the system. And one of those files is called the APK world file. And so when the system boots up, it loads the kernel, loads the modules, and then it takes the APK overlay and overlays it on top of etc. And that tells it all of the packages that should be installed, but they're not installed because they're not here. Then it goes out to the internet, to the mirror, and it downloads all of the packages that need to be installed and installs them. But it keeps the configuration file from our overlay. So essentially what's going to happen is it's going to take the base image, which has the bare minimum kernel and modules, plus our overlay that we're going to generate now, and it's going to rebuild the entire system using a combination of the base kernel, the base modules, the overlay, and going out to the internet to get the packages. Every time it boots up, it's going to do this. So the fewer packages we include, the better. And we also don't really want our users to be able to do that Xterm trick like we were doing. So we're going to uninstall Xterm so the users can't do that Xterm trick like we were doing. We also don't need Git anymore. And we're going to get rid of nano, just so the users can do as little as possible. Don't worry, we can install it later. So now we're going to actually generate the APK overlay using a tool called LBU, which stands for Local Backup Utility. And normally it only packages the etc folder, but we're going to also package home. So we're going to say lbu include home. And that way our overlay file is going to include the user's home directory for VDI, the PVE VDI client, all of that good stuff. And now we're going to generate the file, lbu package, and we're going to call it thin-client.apk-ovl.tar.gz. So this one file here is all it takes to take a bare Alpine system and rebuild it into the complete system we have here. It's pretty darn small. So 939K, not even a megabyte. So combine that with the kernel and the modules, and it's able to rebuild this system. That's pretty remarkable. But now we need to get that file off the system, and this system has nothing installed, so we need to install a new tool. So we're going to add a tool called BusyBox Extras. So BusyBox is a system that replicates a lot of the base Unix functionality like ls and things like that with one executable. And you can compile BusyBox to include more or less functionality. And Alpine uses BusyBox, but it doesn't include BusyBox's HTTP server. So if we try to launch BusyBox's HTTP server, BusyBox HTTPD, we get an error that says applet not found. And that means that BusyBox knows that HTTPD is a valid mode for BusyBox, but it's not been compiled in. So BusyBox Extras is the same as BusyBox, it's just got a lot more stuff compiled in. So we call BusyBox Extras HTTPD, which is the name of server it's emulating, -f-v. And that basically tells it -f and v tell it to be verbose and to not daemonize. So it's going to stay running here. So now the directory we're currently in, which is /root, is being shared publicly on an HTTP server on port 80. And we already know that the IP address of the system is .9.31. So let's go back over to our Netboot server and download this APK overlay file. So now we're on the Netboot server, and we need to get that APK overlay file into our www directory. So we're going to wget it. So the IP of the system, so 9.31 in my case, you would obviously have to remember what it was when we installed the system, or run IP space A to get the IP address. And then the file is called thin-client.apk-ovl.tar.gz. There it is, 917K, that's tiny. So now that's it, we're done. We already set up the HTTP server that's going to serve this file. We downloaded Alpine into the HTTP server. We compile iPXE to load Alpine. And once we boot up a system, it's going to load either the BIOS or the UEFI image from iPXE. iPXE is going to go download the kernel and the intrd and the modules file. Alpine's going to launch. It's going to download the APK volume, which we just saved here. And it's going to reinstall the system. So let's watch what that process looks like. So I've got my Dell Wise 3040 thin client, the tiny one. Video up there when I do a USB power mod to it. So it's booting up. The built-in Ethernet driver is loading PXE, and it's about to download the EFI executable for iPXE. And the EFI file is quite a bit larger than the BIOS file, so you'll find that devices with EFI tend to take a bit longer to boot. At least that's my experience. It's using TFTP at this point, and TFTP is a very slow protocol. So as soon as it can load iPXE, it switches to HTTP, which is significantly faster. So now it's loaded iPXE. iPXE is going to get an IP address itself, and it's going to download the kernel and launch it. And then the kernel is going to go download the APK overlay, download all the packages. So now we're into Alpine. Alpine's launched. Alpine's getting an IP address. Get the same IP address over and over. Alpine has downloaded the APK overlay, and now this percentage bar here is it reinstalling all the packages it needs to install. And it'll take a few seconds, but it's really not that bad. It's going out to the internet here, downloading the packages and applying them. If you're running a big organization and you're doing a bunch of thin clients this way, you should probably think about setting up your own cache server or your own mirror. That'll probably be faster and you'll put a lot less load on Alpine. But for normal users, this is fine. We can go out to Alpine servers. And as soon as it's done, it's going to start up the system. Now it's switched to graphical mode. X has started up. And we got a mouse. And we got a VDI client. And I need a real keyboard. Got a keyboard. Let's see what we can do. I got 3 systems I can connect to. Let's connect to Ubuntu, our favorite one. And Ubuntu is sleeping, and it's awake. We got a thin client. We netbooted it, and tiniest thing ever. Like and subscribe. So if we try to do the xterm trick again, no such file or directory. Not a lot you can do here. You can log out, then it should kick you back in again. And did. So it's working as expected. So as promised, we've delivered. It works. You saw it. It's configured. Hopefully it works in your own setup and you can find this video useful. Thanks for watching, and don't forget to like and subscribe so you can join me on the next adventure.